Let's go into more detail and provide a comprehensive comparison between Starlink Internet, SpaceX's satellite-based internet service, and 4G networks, cellular data services. We'll explore all aspects, including technology, performance, cost, reliability, and future outlook. 1. Technology, Starlink Internet, satellite-based. Technology, type, low Earth orbit, ALEO, satellite constellation. Starlink uses thousands of small satellites orbiting Earth at altitudes between 340 kilometers and 1,200 kilometers to provide internet coverage globally. User equipment, a dish, user terminal that communicates with the satellites, along with a Wi-Fi router. The dish automatically adjusts its angle to maintain the best connection with satellites overhead. Bandwidth and frequency. Starlink operates in the Ku-band, 12 to 18 GHz, for the downlink, and K-band, 26 to 40 GHz, for uplink, which are typical for broadband satellite internet systems. 4G networks, cellular-based. Technology, type, 4th generation, LTE, cellular networks, using ground-based towers to provide wireless broadband access. 4G networks operate in frequency bands, typically between 700 MHz and 2.5 GHz, which are shared among many mobile users within a given range of a tower. User equipment, smartphones, tablets, laptops with USB dongles, or portable hotspots that connect to the cellular towers. 2. Coverage and availability. Starlink Internet, global coverage. Starlink offers nearly global coverage with internet service available wherever you can see the sky, making it ideal for rural, remote, or underserved locations. There are no regional boundaries. It can work in the middle of oceans, in mountainous terrains, or in deserts. Urban and suburban areas. Even though Starlink is mainly focused on remote areas, it works well in cities as well. The main advantage is its ability to provide internet where terrestrial broadband, fiber, DSL, cable, is not available or cost-effective. Potential for expansion. Starlink's coverage is constantly expanding as SpaceX launches more satellites. This global expansion gives it the potential to reach even the most isolated parts of the world. 4G networks, regional coverage. 4G relies on cellular towers, meaning service is available where the network infrastructure exists. 4G is ubiquitous in most urban and suburban areas, but coverage gaps exist in rural and remote locations. Depending on the region, 4G may not be available at all in sparsely populated areas, and in many places, users might only have access to 3G or even 2G networks. Signal range. 4G networks are limited by the range of cellular towers. A user's connection will be strongest when they are closer to a tower, with signal strength decreasing as distance from the tower increases. 3. Speed Starlink Internet. Download speeds. Starlink speeds typically range from 50 megabits per second to 250 megabits per second, with higher-end connections reaching up to 500 megabits per second in some cases. However, speeds can fluctuate depending on congestion, satellite availability, and environmental factors. Upload speeds. Generally, upload speeds are between 10 megabits per second and 50 megabits per second. Starlink's upload speeds are often higher than traditional satellite internet due to the low orbit nature of its satellites. Potential for improvement. As more satellites are launched and the constellation grows, users can expect improved speeds and more stable connections over time. 4G networks. Download speeds. In ideal conditions, 4G download speeds typically range from 5 megabits per second to 100 megabits per second. In urban areas with strong tower coverage and modern LTE Advanced (LTE-A) technology, speeds can be faster, sometimes reaching 150 megabits per second or higher. Upload speeds. Upload speeds are usually lower than download speeds, ranging from 5 megabits per second to 30 megabits per second on average. Speed variation. Speed is highly dependent on factors like signal strength, tower congestion, and device capability. In busy urban centers or high-density areas, speeds can drop considerably, especially during peak usage times, e.g. evening hours, events. Fourth, latency Starlink Internet. Latency. Starlink's low Earth orbit satellites allow for latency between 20 milliseconds and 40 milliseconds. This is much lower than traditional satellite internet, which can have latency over 500 milliseconds due to geostationary satellites, and comparable to many ground-based broadband options. Ideal for real-time applications. Starlink's low latency makes it suitable for activities like online gaming, video conferencing, and VoIP calls, where real-time interaction is important. 4G networks. Latency. Latency on 4G networks typically ranges from 30 milliseconds to 60 milliseconds, but it can be higher in congested areas or if you're further from a cell tower. This latency is adequate for most web browsing, video streaming, and online services, but can sometimes affect real-time communications or gaming, especially under poor conditions. 5G transition. As 5G is deployed, latency will be further reduced to 1 to 10 milliseconds, which will outpace Starlink in real-time applications. 5. Reliability and stability. Starlink Internet. Weather sensitivity. While Starlink is generally reliable, weather conditions can impact service. Heavy rain, snow, or thunderstorms can weaken the signal, causing brief service interruptions. The quality of the signal is also influenced by the angle of the dish and the visibility of the sky. Potential for congestion. During times of high demand, such as when many users are accessing the service simultaneously, the network can experience slowdowns, especially in areas with limited satellite coverage. 4G networks, signal strength, and tower congestion. 4G networks are affected by signal strength, which can degrade with distance from a tower or physical obstructions. Buildings, hills. Congestion is a major issue in densely populated areas, leading to slower speeds or dropped connections during peak hours. More stable in certain conditions. 4G is generally more weather-resistant than satellite-based internet, as it's not affected by rain or cloud cover. However, it's still susceptible to poor signal in areas with limited tower infrastructure, e.g. deep valleys, remote locations. 6. Cost Starlink Internet. Setup. Costs. Starlink requires an initial investment in hardware, including a satellite dish and Wi-Fi router. The one-time cost of the equipment is around $550. Monthly subscription. Starlink's service is priced at $110 per month for residential users. This includes access to unlimited data, but prices could vary in the future based on regional pricing models or service tiers. Additional costs. Users may also incur installation or shipping fees depending on the location. 4G networks. Setup costs. The cost is typically low if you already have a 4G-capable phone or mobile hotspot. No special equipment is needed beyond a compatible device. Monthly subscription. 4G data plans vary, generally between $30 and $100 per month, depending on data usage, network provider, and plan type. For heavy data users, e.g. for home internet, higher-tier plans may be necessary, which can increase costs. Prepaid plans. 4G often offers flexibility through prepaid plans, making it more affordable for short-term or mobile internet needs. 7. Usage scenarios. Starlink Internet. Ideal for rural and remote areas. Starlink is best for users in locations where traditional broadband infrastructure, fiber, cable, DSL, is not available or is prohibitively expensive. Best for global connectivity. Starlink can be used anywhere with a clear view of the sky, making it suitable for travelers, remote workers, or off-grid homes. Suitable for high data users. For tasks like streaming, video conferencing, and downloading large files, Starlink is a good option, especially in rural areas where other providers don't offer services. 4G networks. Mobile and urban use. 4G is well suited for urban areas and on-the-go users who need mobile internet for smartphones, tablets, and laptops. Limited for home broadband. While 4G can serve as a home internet solution, it's usually less reliable and more expensive than fixed broadband in densely populated areas. Perfect for mobile hotspots. Users who need internet connectivity while traveling, camping, or in transit can use 4G-based hotspots for portable broadband. 8. Future prospects. Starlink Internet, growing network. The Starlink satellite constellation is still being expanded, with thousands of satellites planned. As more satellites are launched, coverage, speed, and reliability will improve. Potential for 5G integration. Starlink could eventually integrate with 5G networks to provide even lower latency and faster speeds in urban areas, making it a more competitive solution against terrestrial providers. Targeting developing regions. Starlink has the potential to bring internet access to the billions of people in developing countries who have limited or no access to broadband services. 4G networks. Transition to 5G. While 4G will continue to be available for the next decade, most new deployments and upgrades are shifting toward 5G. 5G will provide faster speeds, lower latency, and better support for high-demand applications like autonomous vehicles, VR, and IoT. Global 5G rollout. As 5G coverage expands, 4G will remain widely available, but users will see a shift toward 5G networks, offering speeds that far surpass both current 4G and Starlink. In conclusion, Starlink is an excellent option for users in remote or underserved areas who need reliable internet where traditional broadband is unavailable. 4G networks excel in urban and mobile environments, providing fast internet with relatively lower upfront costs, but with potential limitations in rural coverage. As 5G evolves, it will likely push 4G networks to the background, while Starlink will continue to expand and improve its service. Subscribe.